I would like to welcome you to the NoDB Breakfast Series. Today is our first event. We will be having multiple events throughout the year on specific topics. Today's topic is entitled Sharing Experiences in Cloud Adoption. We will be having two speakers at today's event. The first speaker will be Matt Aslett, who is a senior analyst at the 451 Group, followed by Seth Proctor, who is our CTO at NoDB. And the presentations will last around an hour, and then there will be a Q&A session, and we have this room available until 10 o'clock today. Okay, without further ado, Matt, please.
Thank you. Hi. So I'm going to keep stepping in front of and thank you for the introduction. Just to briefly introduce myself, so I'm Matt Aslett. I'm Research Director for Data Platforms and Analytics at 451 Research. For anybody who's not come across the company before, you see some details here. We're an industry analyst firm focused on IT innovation. Founded in 2000, you can see here, about 210 employees, just under half of those, about 100 analysts covering the whole breadth and depth of the IT industry. We have over 1,000 clients, including obviously vendors, service providers, enterprises. Also the financial services space as well. And we have, perhaps the most important number about the company, over 10,000 senior IT professionals in our research community who consume our research and help advise us and guide us in terms of the direction that we see the industry going. If you want to know more about 451, obviously, please do just ask me after the speeches. But what I was going to talk about this morning is this data platforms map. You can see here, there is a version available. There's a slightly old version with a mix of printing, but we sort of renewed this one, so we're going to send this one around, I think, on PDF, on email, so you can get the latest version as well. And I was asked to talk about the map itself, why we did it, how we did it, but more importantly, what it represents and what it tells us about the data platform landscape and how it's evolving. So just to start off with talking about the map itself. So, obviously, as an industry analyst, I think we have this urge, somewhat perhaps pathological urge, to put things in boxes. Maybe we didn't get to play with our toys enough as kids, I don't know. But it's also something that clients want to see from us, and they're consistently asking us to help them understand the choices available to them and which products can be compared with others and which don't compare with others, particularly in relation to individual projects. So it's something industry analysts often do, and it's something we certainly did in terms of back in 2011 we were putting together our first report on the emerging database landscape, and we called that NoSQL, NewSQL and beyond, and kind of actually invented the term NewSQL. That's a good thing, it's up to you, but we did for this report to describe the emerging data platforms that we saw and the choices, and trying to get an understanding of why that was happening at that point, that there had been this kind of explosion in the number of products available, and then also where they fit, where they didn't fit, how they could be compared with each other. And this was, or something like this, it's slightly match the formatting, but we came up with this kind of chart at the time to illustrate the different choices. As you can see, it's pretty much kind of an overly complex Venn diagram with different relational, non-relational being the core choices, and then different segmentations based on that. And this was pretty well received. People seemed to like it. It helped them understand these emerging technologies and where they fit. And it did serve a purpose, but almost immediately I was aware that it had a limited lifespan, and the issue, at least became known to me as the drawn to scale problem. I'm not sure if people really kind of know drawn to scale. It was a company that emerged a few years ago and didn't quite make it for various reasons, but they were doing something quite similar to what Spark Machine is now doing, which was a Hadoop-based relational database. And so you can see in terms of this chart, we've got Hadoop up here, and we've got the NewSQL databases up here, so somehow we're going to have to swash these together and it's going to mess up everything in between. And it wasn't the only one, there were various products and services emerging that, you know, you could fit in either box, and everything was going to end up munged on top of each other, and you know, this clearly wasn't going to last. You know, it wasn't something that kept me awake at night, but it was there in the back of my mind that we needed to have an alternative solution to this in the long term, in terms of explaining the market. I had no idea what that was going to be honest. And what happened was, it was a complete accident. I was at an event, as it happens in Germany, and I bumped into a former colleague, and we were chatting away, you know, just catching up. And she said, "Oh, I love what you've done with that tube map." I had no idea what she was talking about. But being British, I smiled and thanked her and just carried on talking. And as we carried on talking, I realised that she was talking about this. And what I realised was, even though she was in the industry, she didn't actually cover databases. So all the words on here were not really relevant to her. So probably when she was looking at this, she was actually seeing this and some blurry stuff in the middle that wasn't really that relevant. And of course, you know, you only have to add a few stops on here, and you realise that actually the important thing was not what's inside the lines, but the lines itself. And this is the way that we could actually illustrate, you know, the convergence of all these different lines of technologies and different product sets. So I realised that that was probably the way we were going to do it, and obviously we had some inspiration to help us. I'm actually based outside London now. I've lived in London for 12 years, I think. So, you know, Harry Beck's original iconic London Underground map has been, you know, something that's always been there for a long time, and you know, that itself has evolved over time. So this is the modern day map, obviously a lot more complicated and a lot more stylised. So clearly, this was something we could work on. Also, I've been a fan for a long time. I've always liked Simon Patterson's The Great Bear, which is a work of art which takes the London Underground tube map, the exact same map, and puts on it sportsmen, famous people, politicians, and this is a really good, I just love it. It just shows you the way that you can use visual imagery to represent something completely different. And so that, you know, obviously was a big inspiration. And then have to give due credit to another industry analyst firm, the Real Story Group, who've actually been doing this for a long time. So they cover mainly the kind of the content technology space. For a long time, we've had this content technology vendor map, which seems to have evolved into digital workplace and marketing technology vendor map over the years. So they've been doing this for a long time. So, you know, we have to give credit to them. It was an inspiration as well, although I personally think we do a bit better. You know, that's just me. So this was kind of the inspiration, but I knew it was going to be a big project, and I wasn't quite sure it would actually work. And it wasn't until, lots of you aware, this was Thanksgiving 2012, and of course you guys are all busy relaxing, eating a turkey and watching football, whatever it is you're doing. Us guys, you know, we're over in the UK twiddling our thumbs trying to find some work to do. It's actually a really good day to get some work done, or to mess around trying to do something that you've been thinking about for a long time. So I just started drawing it, and I started with the NoSQL space because that seemed to be, in my mind, where there was a lot of overlap, and I had to figure that out. As you can see, by the end of the day, I'd already realised that this was going to be a huge undertaking, and perhaps I shouldn't have started. But we persevered, and by December 2012, we had the initial version, which we published, just published on the blog, really, just to get some feedback, see what people thought of it. And what people mainly thought of it was that there was loads of stuff we missed out. Just got the loads of responses about, you haven't got this, you haven't got that, you haven't got this, that, and the other. So obviously we worked on that over time, and we expanded in January, and April, and May, and realised that we couldn't just keep doing this. So what we've now ended up doing is working on it, you know, in the background, and then publishing versions every now and then. So we had a big update in February, which I think is the version you have. We actually had a slight update in September, which is more about the formatting, which is by the by, and then actually a really big overhaul for this version, which is the October version, which we'll be able to send you. So that's the map and how it came about and why it came about. As I say, the most important thing actually is really what it tells us and what we can learn from it. As I say, I started doing it just to see if it could be done. So there was never really any aim that it would have any kind of functional purpose. We have found some interesting functions for it. It's actually quite enjoyed in the investment community in terms of them picking out companies that have invested in and trying to figure out obviously who their competitors are, or who they, following the lines to figure out who they could invest with, which isn't competing with their existing investments. I did hear of one person apparently that in the NoSQL space was just going around from stock to stock having interviews and trying to figure out where he was going to choose to go and work. So, that's maybe one use of work. But, it is what it is. But as I say, the more interesting thing is what it tells us. And I think what it tells us, it's interesting to look back. And obviously we didn't have the map 5-6 years ago. But we can sort of take things away and we can try and figure out what the map would have looked like 5-6 years ago. Based on our coverage. And what we see is, there were some interesting things happening, kind of isolated around stream processing, and grid and cache technologies. But really the market was obviously dominated by the incumbent providers, as in terms of market share and revenue it continues to be today. Some specialists in analytics and non-relational, but really the bulk of the action's happening here. And what happened over that time frame is then obviously the expansion of these existing markets, new players into the market, also some consolidation, some M&A activity, particularly the analytics space. But the market then began to really evolve in 4 main areas. So we saw the emergence of this NoSQL space, the new breed of non-relational databases. Then the new SQL space, the new breed of relational databases designed more for kind of modern day distributed cloud architectures. And then obviously Hadoop, a whole new ecosystem of providers emerged around Hadoop. And then lastly, I always put it last because it tends to bring everything together because everything's now being delivered as a service. So we see some specialists over here, but really brings everything together in terms of the new providers. And really what we can think of this as almost like the ongoing expansion of the universe, and the database space for that 5-6 years just seems to keep expanding. And one of the things we get from our clients is a lot of questions about why this is happening, what's driving this, particularly in these 4 areas. So if we look at those 4 areas, NoSQL, new SQL, Hadoop, and database as a service, there's a lot of different things going on which is driving innovation in the space. But for us, they fall into 3 main buckets, which is about applications, about developers, and about architecture. Now obviously all of those things influence each other. I won't read these out. You can see obviously all the applications and developers closely related to architecture, implication on applications, etc. So they do all influence each other, but of course we can't look at them as one whole, so if we just skip through them individually. In terms of applications, we see that social, mobile, global, local drivers for new application projects all have significant implications for data connectivity. So if we talk about social, we see this increased interaction from users generating more data, consistently generating more data. Obviously mobile access being a big part of that, but mobile itself is kind of another driver in terms of different form factors, different access methods, different requirements in terms of data delivery. Global, I was having a conversation with a client the other day and saying, could you get away now with launching a new application or service only in a certain part of America or just in Britain? I just don't think you can. People expect everything to be available globally. If not immediately, then pretty quickly. And also local, so both in terms of local delivery of content. So you expect to get the same performance from your application or you hope to get the same performance from your application if you're in Europe reviewing the US. You expect that local delivery of global content. Also, of course, you expect local content. You want local data. You want to go find the hotel, the restaurant, or whatever it is that you're looking for. So you expect that localized content based on knowledge of where you are. All these things are putting new implications on data delivery. Obviously, each of these things we could do a whole presentation about, but in the interest of time, we're going to skip through it pretty quickly. In terms of developers, this is in particular, we've got a whole group of, within 451, of my analyst colleagues who focus on developer interest and DevOps. But what we see in relation to the database space is that developers are increasingly driving data management choices, data-based selection in terms of the DevOps movement and the shift towards continuous delivery. As I say, driving the choices about database with rapid development. In particular, we see that as somewhat inconsistent, again, we could get into this in more detail, with kind of traditional data management and processes, in particular data purchasing processes. And so there is this growing need to unite the application development and data management people and processes to achieve common goals. To some extent, this is happening. This quick snapshot of a survey that, as I say, some of my colleagues did, looking at organisations that are already putting DevOps into practice. And the interesting thing I found about this was looking at why they are reducing release cycles and why they're moving towards this more continuous delivery. As you can see, just over half are doing it for business and strategy reasons, competitive advantage, business productivity, revenue generation. Just under half are doing it for more kind of technology reasons, so functionality, new feature sets, reduced development costs. So as this whole DevOps movement kind of matures, we expect and we think we will see, the alignment of those two things. There's a split. I don't think it's a problem because both of those are positive moves, but they need to align within organisations rather than within the industry as a whole to drive forward development processes. In terms of architecture, what we see is, in terms of database architecture, a transition from traditional scale-up approaches towards more distributed databases. And this was actually kind of one of the core focuses of that NoSQL, NewSQL and Beyond report. We were looking at kind of the evolution of some of these databases. And what we came up with there was this idea about database spraying. So over the years, the existing relational databases have been asked consistently just to do more, to deal with objects, to deal with XML, to deal with distributed environments. And spraying is when you stretch something almost, but not quite to breaking point. And this is what we see a lot of database administrators dealing with, that their database landscape is just straining under the pressure of this. And if it's not the database that is, then it's the administrator themselves who's having to manage all of this complexity. And spraying, obviously, as you see, is an acronym, which stands for kind of the 6 key drivers that we saw for enterprise interest in some of these emerging technologies. So scalability, performance, relaxed consistency, agility, intricacy, and necessity. Not all of them obviously necessarily at the same time, but if we look at different projects, we often see a combination of 2 or 3 of these that are driving organisations to at least look at emerging alternatives. Of course, in relation to architecture, as well as the shift to distributed databases, we also see a shift towards, say on-premises computing, say traditional, on-premises computing toward the cloud, public-private hybrid. Today, by and large, we do see these trends happening. They are clearly running in parallel, but they're not really as united as they could be. So you've got the infrastructure team thinking about the next generation infrastructure choices. You've got the database administration team, or even, perhaps sometimes the developers thinking about their next generation database choices. And a lot of the same themes are driving them forward, but they're not as united as they could be. And we think that will increasingly be the case. We'll see these teams kind of working together and a lot earlier in terms of planning that next generation infrastructure. Just a quick word on public cloud databases as a service. We do see some interest in public cloud databases as a service. The interesting thing though is if you look at Amazon Web Services top enterprise use cases for Amazon Web Services in general, in order the most popular, so development and test, new workloads, supplementing existing workloads, then things like migrating existing workloads, the migration of an entire data center, or what they call in cloud, a startup, everything they do is in the cloud. So I think that the top three of those are the three most popular use cases for public cloud according to Amazon Web Services are actually additive to the existing database landscape. It's not about migrating existing workloads, it's not about displacing existing workloads. It's about new projects, new applications. And this is something we consistently see, that public cloud has a role, we increasingly have a role, but in terms of displacing the existing infrastructure, it's not happening at this point. Again, we've got a whole other team of analysts that focus specifically on the cloud. And this is some research that they've done from Cloud Computing Wave 6, so talking to those organizations that are part of our team of 10,000 end users. And what we see is obviously the majority of workloads today out there are on internal, in-premises, non-cloud, traditional infrastructure. But as we see that dropping to 41% in a couple of years, and a shift towards more kind of private cloud-based from 19% to 30%. So say in terms of public cloud, it is being adopted, it is growing, but it's not, it's not having a significant impact in terms of growth. So 5 to 9% for software as a service, 1% to 6% for, we say, other than SaaS, so infrastructure as a service or platform as a service. So it's growing, but it's not having that significant impact. What we see actually growing more is hybrid cloud, so 10 to 25%. And it's our view within 451 Research that the future of the cloud is hybrid. And actually for enterprise applications, and by obviously we're talking about traditional database-based applications, if you like, the route to the hybrid cloud is private. So if you look at enterprise applications, be they customer-facing, back office, they are predominantly for the next 2 years going to be delivered on internal private cloud with potentially after the hybrid cloud. They're not going to jump to public cloud. It just there will be some isolated organizations that do that, but by and large it just isn't going to happen. So back to the three drivers for change and influence specifically on the database space. So obviously I talked about the fact that these all influence each other. Clearly we must recognise that actually it's a combination of all three that's driving adoption of and the emergence of kind of NoSQL, new SQL Hadoop, and databases as a service. So these new database types do have some things in common, but obviously they're actually very different in terms of the use cases and the types of technologies involved. We look at NoSQL, we're talking about non-relational data models, not always, but most often trading off consistency for availability. Compare that to new SQL, we're talking about obviously maintaining that probably the best aspects of the relational data model by adding availability, flexibility, and scalability to that. Hadoop, obviously, actually quite different. We're talking about batch, increasingly also interactive, but traditionally batch analytic processing of unstructured data. And then database as a service is something of a red herring in that it's not actually, it's really like the deployment model. It's not a different class of database. It's all of the above, or indeed a traditional relational database being delivered as a service. So in terms of the core kind of use cases, we see NoSQL being used predominantly, or obviously again, we can do an entire presentation on each of these, predominantly for kind of non-transactional operational applications, dealing with unstructured data and lightweight query. Compare that with new SQL, we're talking then about transactional operational applications, more structured data, more complex query, increasingly what we call operational intelligence. Hybrid transactional analytic workloads. And then Hadoop, obviously non-transactional analytic applications, multi-structured data, clearly complex query, lots to see. Here's some examples if you've not come across them before. And then obviously, as I said, database as a service, a bit of a different one really, but any of the above, or a traditional relational database management service delivered as a service. Obviously, there's whole different arguments about whether why and whether you would deploy as a service versus on premises traditional deployments. So we've seen this expansion of the database space as I described over the last 5 to 6 years, and we ought to think of this, as I said, about you can compare it to the continuing ongoing expansion of the universe. And kind of driven, as I said, I haven't used this idea, but polyglot persistence, and not come across it before, is this idea about using specialist databases for specialist workloads. And so a lot of adoption of particular, the different NoSQL databases being driven by this in recent years. And that, that gives you some advantages, but what we found is that you potentially get to a point where you have even a single application which has 2, 3 databases underneath it, that's supporting that for different kind of data models or different transactionality requirements. And that obviously introduces administrative complexity, development complexity. And so we've seen a little bit of a shift. I mean, it's still early days in terms of this, but we have seen a bit of a shift towards organizations looking at what we call multi-model databases. So databases actually, you still want those multiple models. You don't necessarily want 3, 4 databases to deliver that. Obviously, there's trade-offs involved in that, but it's an interesting emerging space, especially when you consider there's the potential for kind of NewSQL to get involved in that as well. So we've seen the NoSQL vendors increasingly adding SQL-like capabilities to their databases. Some in terms of actual proper SQL itself, and obviously the NewSQL vendors see an opportunity to add support for, say, storing JSON documents or some key value access to that. So the lines are continuing to blur between these different database categories. I'm thinking ahead about where this might end up. Certainly, we talk about database as a service or X as a service here in terms of being a deployment model. So it's wrong to think of it really as a different category. It's really about how you want to deploy your database technology or consume your database services. There's also an interesting thing potentially with Hadoop, in particular in relation to the Hadoop distributed file system. Certainly in some organizations, and so we're looking further ahead, but we are seeing this happen in some early adopter organizations where data gravity, so much of the data is now in the Hadoop distributed file system. The data gravity means that the applications and other database services are being drawn to that data rather than them wanting to pull data out and move it around. So there's an interesting prospect that kind of HDFS becomes kind of a common substrate for multiple data processing models and engines on top of that data in HDFS. It's not going to suit every requirement, obviously, but as I say, we are seeing some interesting projects working in this direction. So there is an argument to be made, at the very least, if we're thinking about where this market's going in the next 5 years, rather than looking back at the previous 5 years. But these potentially, we're talking here not about different database technologies to be deployed in isolation, but actually the building blocks of a next generation data platform. So I just want to finish off in terms of thinking about how we get from here, where obviously there's lots of different organisations in different stages of development and adoption around database technologies. But I think we can see that the mainstream still today is on in this space centralised scale-up SQL relational databases being the majority of their database landscape. And we see that organisations are thinking about and wanting to work towards a place where they have this next generation data platform, which is multi-tenant, multi-model, multi-data center, hybrid, agile, elastic, distributed, delivered as a service, and automated. Actually, a lot of things which you could use to describe what the traditional relational database isn't. And so the question is how you get from here to there. This is kind of a work in progress. I'm really interested to get feedback on this. This is a bit of kind of more blue sky thinking about where things are going. But certainly we've seen, what we might see over the last few years is this shift towards tactical deployments of new SQL databases, NoSQL databases, Hadoop databases, etc. Proof of concepts and kind of individual departmental application-driven deployments, often driven by shadow IT. So there's been, as I said, this kind of tactical expansion in terms of the number of databases that organizations are using. We talked about the move towards multi-model, and what you can sort of think about that as being this more kind of tactical consolidation. So organizations looking to reduce perhaps the number of different deployments that they have in terms of the number of suppliers, looking at managed databases as a service. SQL and Hadoop, we've kind of put in this category because you've got your army of SQL developers and administrators, you've got Hadoop, you want to bring those worlds together, and that's why we've seen this big focus on SQL and Hadoop in the last few years. Federated queries kind of part of that. But at the same time, there's been this kind of tactical consolidation of projects. There's been a strategic expansion in terms of the types of applications and the mission criticality, if you like, of the applications that are being deployed on these databases. And they are becoming increasingly important to organizations in terms of their, if not their core enterprise applications, but their, those next generation applications. And we're seeing increasing move towards strategic vendor relationships driven by traditional data processing policies and requirements, rather than this kind of developer-led shadow IT adoption that we saw before. So this, as I say, it's kind of a work in progress and interesting feedback, but this seems to be the way we see the shift going towards then a more strategic consolidation, where we will see, I think, some M&A activity, definitely. That's what happens in this space. And we will see some consolidation from users demanding these different providers to work together more and bring their technologies together. And in terms of, we talk about multi-model, we've already seen this in terms of the core functionality, the core data models and approaches. So what this means in terms of the, our map, just to bring things back to this, I think we'll see, quite a few of these stocks vanish, either through M&A or through, they can't all make it. It's just not it's not the way the database market works, particularly when a lot of the money seems to be consolidated. Yes, we will see M&A, we will see companies disappear, but what I think we'll also see is these lines becoming increasingly blurred and really being drawn across the map. We've already got Oracle supporting the ability to store JSON documents in there, and IBM doing that, and so the lines are really coming together. So whether this will actually continue to make sense and be usable, I'm not sure, but I hope so. But for now, it works, and so we'll stick with it. So that's what we have for now. Thank you for your time. I hope that was potentially useful and interesting. I hope the map may prove useful for you in whatever way it might do. And as I say, we will send you the latest version of that. I think we'll go on to the next presentation and maybe have some questions after. Yes, but yeah, thanks very much for your time.
Good stuff. Thanks, Matt. So hey everyone, I'm Seth Proctor. I am not going to show you nearly as many pretty pictures as Matt did. I apologize in advance. Matt is, if you haven't come across his stuff before, I highly recommend you go track it down, do some reading. I think he's doing a lot of, not just the subway map, which I think is really cool, but he's got a lot of good stuff he's been writing kind of on where we're going in the industry in general. And he and I have been doing a lot of talking lately and kind of thinking in the same lines. And so what I'm going to try to talk about today are a couple of things. I'm going to talk to you about what UDD is. For those of you who are interested in that, I'm going to show you a little bit of the demo at the end of this talk. But I want to start by kind of continuing that line of thinking that Matt was putting kind of around this trend that we're starting to see around consolidation, this trend around kind of multi-model, and talk a little bit about why that's interesting, but also architecturally why it's challenging. At NewDB, we use the word architecture a lot. If you ever been to one of our talks, if you've ever read any of our papers, if you found out front the book we have that is our architecture white paper, we really focus on architecture, because we really believe that there are systems that are well suited to do certain kinds of problems and systems that are not as well suited to certain problems, and that when you have a core architecture that's designed to be flexible, when you have a core architecture that's designed to solve different kinds of problems, it lets you tackle some of the things that Matt was talking about here. So in particular, you just heard kind of this commentary on conversions, right? Matt mentioned at the end things like Oracle implementing JSON, right? We certainly see this kind of thing happening, I think, increasingly in our industry, right? We see NoSQL systems adding things that look more like traditional AST systems, traditional SQL capabilities. If anyone's looked at Cassandra recently, right? When people talk about capabilities through CQL, if you go talk to people at data stacks, they're talking about how they're adding in essentially limited transactions into the system. If you look at the non-AST systems out there today, they're increasingly trying to figure out how do we get some notion of consistency built back into the model. Maybe it's not full transactional consistency, maybe it's single statements, maybe it's transactional consistency on a single table or on a single element of your schema. Maybe it's some limited ability to run some kind of operation but not a join. Or maybe a join but not a join across more than one element. Maybe it's time limited. There are other kind of little hacks that people are putting in place to essentially say, how do we get towards something of a transactionally consistent model where there didn't used to be one? Again, the reason that's hard, well, aside from the fact that supporting transactions, that's kind of a hard thing to do. But the reason that's hard is again, it comes back to the architecture, right? The systems that are designed to be able to handle a transaction consistently. Matt mentioned earlier that many NoSQL systems, or specifically non-AST, non-transactional systems, have often taken the approach of trading off availability for consistency, because that ends up being an easier technical trade-off to make when you're actually building a system. It's arguably easier to build something that is available by sacrificing notions of consistency. It's just that then your application developers pay for it, because they don't have a transaction model. They have to figure out some way to sort out the mess. And yes, you do see a lot of SQL databases adding support for things like JSON, adding support for key value interfaces, adding support for RDF and other map, other graph style APIs. And you do see increasingly this interest in kind of how HDFS and SQL work together. I'm not sure I'm in the camp of people who believes that Hadoop and HDFS is going to be the core for everything. I think it solves some very good problems. But again, I think when you come back to the core architecture, it's designed for a set of problems. And I'm not sure I believe it's kind of a ubiquitous framework that lets you solve all the different kinds of problems that we really care about. The interesting question is, why is this happening, right? Why now, and why is this happening in our industry? And completely agree with Matt. The subway map is maybe going to be easier to draw in a few years. Completely agree that we're moving towards this trend. And I think Matt talked about some of the reasons for why this is happening, right? And one of them has to do with simplicity. One of them has to do with the fact that you don't want to have to maintain 4 different database technologies, 6 different database technologies. I've talked to companies that are literally deploying dozens of different databases. Have tens of thousands of database instances, and they're juggling, many dozens of different technologies, and those are all different, and they're all running at different versions, right? So you've got lots of different technologies, lots of different assumptions about consistency models, lots of different APIs, lots of different bits on disk that you have to maintain and manage, different provisioning models. It's a mess. And so I completely agree. That's one of the core key reasons why people are looking to try to solve more problems in the same technology. I think another aspect of simplicity increasingly is about the data itself. Right? So something that we're increasingly concerned about as you scale across a data center, as you scale across multiple data centers, as you start thinking about geographic scale, one of the real problems that people are facing is what happens to that data as it starts traversing different technologies in different locations, right? So if anyone has thought about deploying a service in Europe, right? It turns out Europe, while it sounds like it's a nice big boundary and everything in it is the same, like anyone who's ever been to Europe knows that that is far from the truth, right? And while there are laws that govern the EU, if you're going to deploy a service in Europe, and you've got German citizens, and you've got French citizens, and you've got Italian citizens, and they're all using your service, their data needs to be managed differently. It needs to be stored in physically separate locations. It has different rules of audit, it has different rules of governance, different rules about retention, about who can access that data in what locations. And so just when you step back and think about a really simple problem, like you've got your operational database and you're doing ETL out of it on a regular basis so you can do some batch analytics, well, now you've got 2 copies of your data. So there's simplicity, like I don't want to have to do that ETL operation. I don't want to have to maintain 2 databases. But there's also simplicity of like, I really wish I didn't have to worry about the audit trail and the governance and everything else of that data in 2 different places as well. And that, I think, is becoming increasingly a driver here. The other reason, like, we're starting to understand how to do it, right? So we didn't have this explosion of hundreds of databases because we had a generation of people who said, you know what I really want to do today? I want to invent like the N+1 database. Like that's not really, I mean, that does happen. Like there's a time and place for everything. It's called college, right? I mean, we all go to university. Thanks, someone laughed, thank you. We all go to university. I know it's early in the morning, but come on, guys. We all go to university. We all go through that. Like we all rebuild an OS or a database or a something like that in computer science. And then we realize that like in the real world, you don't really want to be in that industry of constantly reinventing things, right? But databases really are fundamentally hard systems to build. And the scale and the scope at which we're trying to manage systems today is crazy, right? I mean, distributed systems are really complicated. Database systems are really complicated. Networking is really complicated. You put all these things together, it's hard. And so we really had, I think, part of the reason we had this explosion of technologies for a long time was because as technologists, we're very good at looking at the tools we have in front of us and coming up with pragmatic solutions. We're very good at saying, tomorrow I need to be running on 10 times the number of machines I'm running on today because I'm about to get slammed. It's Black Friday. And I've got to do something, or if you're in Europe, it's sale day in France, right? Or it's like Singles Day in China, right? This is around the world, this happens, right? I've got to figure out some way of making the scale now. And technology is not there to just take my Oracle database and make it do that, or take my SQL and make it do that. And so we've built a lot of tools that got us over those scaling limits. And it is really hard to say, well, let's actually step back and take half a dozen years and rethink the architectures and rethink why those technologies don't scale well. And then try to build a solution that actually solves them the way we would like to do from the beginning. Right? And I think that's what's been happening in the industry over the last several years. These companies like ODB, we're not alone. I like to think we're doing it in a pretty interesting way. But there are several technologies out there that are basically stepping back and saying, if we could have done it right the first time, how would we have done it, right? And so we're hitting that tipping point now where we really understand what it is about these other approaches that traded off things that we didn't want to trade off, where the complexity is coming from trying to manage multiple systems or trying to conflate lots of technologies in the same place, and how do we build new architectures that actually address the problems we care about today. So multi-model. Multi-model, I think, means a lot of things to a lot of different people, right? And obviously, yes, it's, I should be able to do document, and I should be able to do SQL, and I should be able to do graph, and I should be able to do whatever else in a single thing. Or I should be able to solve kind of, operational stuff and analytics in a single thing. That's simplicity, it's really nice. But I'm going to argue it's less about, is it SQL or is it JSON or is it something else? But it's really fundamentally about how the data is used, right? It's about what is that model for your data? What is the expected access pattern, right? Because this is how you optimize a system, right? So again, it's not about like slapping on a new front-end parser. It's not about like being able to support a new data type you can get to before, right? It's about understanding, when I said I have a SQL database, and now I really want JSON. What does that mean? Like, why do I want JSON? Yeah, I mean, I've got a bunch of like web hackers who I'm bringing on, and that's what they know. Great. But what's really going on? What does that mean in terms of different access patterns? What does that mean in terms of different assumptions around security? What does it mean in terms of how the data should be indexed and accessed, right? What are the optimizations? What are the things I care about? What are the things I don't care about? And can the architecture, can the underlying database understand how to give you those kinds of scaling benefits? Not just does it understand how to parse SQL or parse JSON and turn it into something, but can actually give you those kinds of performance characteristics you want, right? This is what drives those access patterns. This is what defines where you should store data and how you should store data and how you think about, do I need a fast disk? Do I need a slow disk? Do I need multiple disks? Can I parallelize something? Can I not parallelize something, right? RDF tends to be used for applications that are highly parallelizable, right? They tend to be things that you can distribute in a way that is harder to do with SQL. JSON tends to be kind of flat, and then it's primary key indexing that is really critical. These are different assumptions about how you would structure the data underneath and how your architecture should react to them to be able to give you really, really good performance. Ideally, I would argue, I know this has kind of not been sexy for a long time. I think it's making a comeback. Transactions are a really good thing, right? There's a lot of discussion, I'll say generously, there's a lot of discussion today in the media and kind of, in the NoSQL community about how transactions are heavyweighted or bespoke and it's really archaic things that like a few people want, but most applications don't need them. I'm going to argue that actually transactions were invented as a utility, right? They were invented to make our lives easier, to simplify failure cases, to simplify rules of the system, to make it simpler to program systems that are resilient and can scale. And to be more hands-on, to work with a declarative interface like SQL, so that you tell the system what it is you want to have happen, not how the system should do it. And then you let the system optimize how to actually do the thing that you want to do as effectively as possible. And so I think ideally, this whole multi-model world is also about being able to wrap a transactional boundary around more than one set of data, around more than one use case. And being able to do it in a way where your core architecture understands what the problems are you're trying to solve and can optimize for those different sets of problems even though it's in one system. And I think this is where the architectures in the next 5 years get really interesting. This is where it all gets differentiated. And let's take an example of why that architectural differentiation is so important, right? Matt talked about database as a service and how database as a service kind of initially was specific products. It was things that were offered as a service, but then it started to become more just a general model that you assume you want to be able to support. Right? Well, if you've ever tried to take one of the traditional relational databases and deploy it as a service, right? What you've done is you've figured out some way of wrapping in piles of scripts and building lots of complexity around it, and somehow getting it into a cloud model or a local data center model. And in the end, you haven't really built a service. You build something that's kind of abstracts it, that makes it a little bit easier to get the bits installed somewhere, that automates the process of like doing it again when you need to do it. But it's not really a service in the sense that you can just kind of hit a button and something spins up in your data center or in the public cloud, can scale on demand, can give you what you need in terms of resource capacity on demand, and it's just a single endpoint. Right? And again, that's because of the architecture. The architectures were not designed to do that. And this is something that we want increasingly from everything we do, right? When we deploy stuff, when we think about cloud models, we think about our application tier as being something that can be treated as a scale-out service. We think about our web tier as something that can be treated as a scale-out service, load balancing, storage. We want the database to be able to do the same thing. And in particular, we really want it because we want to get more and more towards a notion of whether you call it automation, whether you think about it as autopilot, whether you think about it as some way of being able to get a service running and then make it self-aware. That's where we want to get to. Because again, these large systems we're talking about are very complicated. right? And while we've had this big trend towards DevOps in the last few years, and everyone's really excited about it, again, I think DevOps is one of those things that is pragmatic in nature. Right? We didn't really know how to decouple the development experience from the operations experience as we started building more and more complicated systems that required embedding in your application logic and knowledge of how your database works. So we have these very rigid things, and then to make them scale, to change your operations model, to scale out, to add more machines, to react to failure, requires knowledge of what's happening in development. Right? I think what we really want to get to is we want to get to the point where we can tease those back apart and say the database is a service. The database is a service that is automatic. I can describe, again, just like SQL, I can describe what the problem is I'm trying to solve, not how to make that problem happen. Right? I can describe an SLN. I can say, this is the database I want. It needs to be able to solve these kinds of problems. It needs to be able to support these models. I need these kinds of resources. I need this kind of capacity on demand. Make it happen. And now I'm going to go focus on my application, or I'm going to go take vacation. You know, whatever it is you do there. And this is not a nice to have. This is not a like, wouldn't it be cool if we had this, right? Because when you start talking to people in the enterprise who are, as Matt says, trying to get to that cloud model, right? We're trying to move from a pure on-premise model either to something in their own data center or something in other data centers, something public cloud. We're trying to move toward a service model. The limits of scale people are talking about are crazy, right? I mean, I regularly talk to people who say things like, well, I've got 50,000 databases running, right? Or I'm running in 25 data centers. You know, I've got this many applications, I've got, you know, whatever. And they say, well, how do you manage all of that, right? And I recently talked to someone who had this incredible answer. They're like, well, I have whatever, percentage of, like literally, like this is my percentage of the network traffic that's running through the world, and I know how it's being managed, blah, blah, blah. And I've got my data center with a dock, and there are 4 screens in it. There's someone who sits in front of it. That's it. It's management system. Right? And the only reason you build a system that's that complicated and that scales to those levels of extremity is because this is how they think. Right? It's not about like provisioning as a nice simple thing that I can plug into my chef stuff and then I have a DevOps person who's always sitting there monitoring. But you can't hit these next generation limits of scale that we want all the multi-model stuff for, that we want real graceful architecture for, unless you also think about a way of setting it on autopilot and just telling you something is wrong. And that's as critical to scale as things like core storage. So where does that leave us? Kind of in Matt's vein of what's happening next, right? I think there are a couple of requirements when you think about what you want from a distributed database in this cloud stack. I think it needs to be able to scale in and out on demand, right? It should be something that can use resources on demand when you need them, drop them when you don't. Part of what that does is that gives you transactional flexibility, lowest total cost of ownership. Part of what it does is it provides resiliency, right? It provides you a model for always being able to handle failure. It provides you a model for always being able to get ahead of failure. It provides you a model for being able to do online upgrade, online maintenance without taking down the database. You should never buy a product from someone who claims 100% uptime. Like, pro tip, 100% uptime doesn't exist. But you should always design with 100% uptime in mind, right? That's a thing you aim for, probably not something you achieve. But like that is something you want. And you want an architecture that has the audacity up front to say this is designed for 100% uptime. But you can't scale. You can't scale your development team. You can't scale your operations team. You can't scale around automation if you're doing any of the weird tricks around sharding or active passive models or latencies between when you can write something and when you can read something. You want a database that looks like a single logical database. And because it's a single logical database, you can make operational changes without affecting application logic. Because it's a single logical database, you can run it wherever you want, and it doesn't matter. It's a resource allocation problem, not a development problem. Because it's a single logical database, your application developers can start thinking about the next generation of what they're doing without worrying about where it's going to run. Is it hybrid? Is it public cloud? Is it on the local data center? Is it a mix of things? It doesn't matter. It's a database. I think you absolutely want the multi-models we've been talking about. You want that across mixed infrastructure, right? If it's multi-model and scale out and hybrid, but every machine in the hybrid cloud has to be the same footprint, same size disk, the same memory, then you haven't really gotten to the scale you want. It needs to be something that can run mixed resources, something that can run in multiple locations, and be something that is simple to use. Because if you're doing all these crazy complicated things and it's not getting easier and easier, you're never going to be able to take advantage of all these neat things. At NoDB, we kind of talk about architectures in a couple of buckets, right? We kind of talk about two traditional architectures that people use when they talk about distributed databases. And without going into a lot of detail, this is probably familiar to a lot of people in the room. There's the shared disk view of the world. So I'm going to argue something like RAC from Oracle represents something of a shared disk model. There are other systems that are built around essentially scaling out the disk substructure. That works well because a lot of our current databases today are still based on the system of our architecture from the early 1970s, are still based on a fundamental scaling assumption. That's kind of cool. Like, it's amazing that that idea has such longevity, but it also suggests that probably we should be looking at what's different today in our architectures. There's also the shared nothing approach at the other end of the spectrum. And whether you think about that as a sharding solution, whether you think about that as a replication solution, essentially it's the main thing that we use to scale things in the cloud. It's take a database, chunk it up into lots of smaller disjoint databases, and then you can scale those databases independently. Again, it's a nightmare in terms of the number of copies of data you have, the different places where the data lives. There's no ability to think about a single consistent view of the world. Now your developers and your operators have to work very closely together, make sure they understand exactly how something is being separated. But it's pragmatic, it works. Right? Really interesting solution that's come out of Google the last few years is Spanner. On top of Spanner there's F1, on top of F1 there's Mesa. Wait, Mesa? That's right. Sorry? I think, yeah, the Mesa, there's Mesos, and there's like a third M1, and I'm always getting the things. I think it's Mesa. Really cool stuff, right? Really, really interesting. And really interesting in part because 10 years ago, it was Google that stood up and said, you don't have to do SQL anymore. Like, we're Google, and we bought into the idea that key value is like a totally acceptable way to do enterprise. And here's big data. And everyone was like, oh, okay, I guess key value is the way to go, right? And 10 years later, they've gone the other way around. They've said, actually, AdWords, our only application that actually makes money, requires SQL. Like, without SQL, we can't make it scale. And by the way, we're moving a lot of our other core technologies onto a relational database. And by the way, we don't think MapReduce is the future. So interesting politically what they're doing, but also really interesting technically. If you haven't read the F1 paper, I highly recommend going and reading it. It's like 10 pages. It's surprisingly readable. It's very clear why it works. Right? And why it works is because they bought a whole lot of atomic clocks, they bought a whole lot of high-speed networks, they chunked their schema up into very specific models that map well to the geographies and assume something about how the transactions will run across those schemas. And if you can do that and you're Google, good job. For the rest of us, we've tried to come up with a fourth architecture, something that is called the durable distributed cache. And it is exactly what it sounds like. It's a system that assumes that in-memory is important, that the way you scale a system is by running in-memory through a caching architecture, that is something you will want in a cloud environment, but that to be a relational database, you have to be durable. And so you can't skimp on that. You can't say, well, it's eventually durable, or it's durable, but in these failure models it doesn't work. No, you need something that is a cache that understands the rules of a transactionally consistent database. You need to be durable. But you need something that can scale out very effectively for these kinds of models we're talking about. And at a really, really, really high level, this is what NoDB looks like. Right, which is totally different than what you see in any other kind of database architecture. Right? NoDB is a pure peer-to-peer system. It's a system where there is no central coordinator, there's no master process, there's no owner for any particular piece of data. It's a true egalitarian vision. And it's made up of these independent peers in the spirit of a good distributed system, right? It's distributed in that formal sense. It's a set of peers that are all running completely independently, but understand on what points they need to coordinate with their peers and know how to do so. right? So it's a system where any one of these peers can fail at any point, any new peer can be added at any point. And the only difference between these peer processes is they understand that they serve one of two roles in life. They're either in-memory peers that have no interaction with disk. That's where SQL clients actually connect to the database. That's where transactions are run. That's where we maintain atomicity, consistency, and isolation. That front end is also where we understand SQL. But separate from understanding SQL, there's a whole core of the system that understands all of the rules of ACID transactions and how to avoid write-write conflicts, how to make sure that data is consistent at all time, how to coordinate among multiple cache copies of data, how to optimize caches, how to optimize the transactions that are actually running. So we think about SQL in that whole multi-model sphere. We think about SQL as a very different problem than how do you optimize for a scale-out transactional system. And then we also have these peers down here that focus on durability. No clients talk to them, they don't care, they have no idea that it's SQL. All they know is that there's a distributed object system and that they're part of that distributed object system and that they can make data durable and they can provide access to that durable data as needed. And in fact, because this is an object system, our storage tier is very simple and it really is a key value system. And so out of the box, this could be disk, this could be S3 on Amazon, this could be HDFS. To us, kind of that storage tier matters a lot less than how you build out the rest of this peer coordination process. And again, this just becomes now kind of a question of resource management. What's the problem you're trying to solve? How many dollars do you have to bring to bear on the problem? Where do you want your data? What about the reliability models? So you can have independent points of storage, you have independent points of access to the database, and it's wrapped in a formal provisioning and operations model. And so there's a management tier running here at all times that you can access through our tools or through our APIs. We don't care if you use our tools. That gives you information on data, that lets you actually start and manage and stop all these processes, that lets you keep track of what's happening at all times, and lets you do some really interesting things around automating a system. At a high level, on that requirements list, this is really what we're talking about, right? Something that can do scale out on demand, very high levels of transactional throughput, very low latency as you scale out. Something that's designed with continuous availability in mind for failures, but also for live upgrades. Something that can be distributed not just across a data center, but across multiple geographies, and can continue to give you low latency access for those applications that are designed to scale out. Social apps, operational applications, logging, account management, session management, all of those things where, applications that follow the line of the sun. Things that actually scale out will be things that give you low latency, high availability, and some really interesting rules around data durability. Multi-tenancy as a first-class solution that's actually designed at that architectural level to be based on process-level isolation, separate security credentials, separate storage locations. So you get a single place to manage the system, but you can do all the traditional kind of approaches to multi-tenancy, but you can also get real isolation without having to, buy a big honking Exadata system and use pluggable databases or whatever we call them these days. I'm going to give everyone just a couple-minute demonstration because I think this is kind of interesting. So this is from the new version of the software we've been working on, Unity 2.1. There's a beta available. This is actually bleeding edge. This is like Saturday night's build. So you're like the first human eyes outside of Unity to see this set of features. But just to give you an idea of why I'm harping on all of this around kind of the things that we usually don't talk about in databases, the simplicity, the automation, the management tools. I haven't been talking all about TPS. I haven't been citing TPCC numbers. I haven't been talking about SQL isolation. I haven't been talking about what our syntax is. We do all that stuff. We're happy to talk with each other, right? But when we're talking about scaling out a database going forward, we're talking about the generation of things we're trying to build now with cloud in mind, these are some of the things that I think are just as critical, right? So what you're looking at here is you're looking at our new web-based console for managing our system, right? And again, this layers on top of APIs, so you can use our web GUI, you can use our command line tools, you can use a REST API, Python API, you can interact with our system wherever you want to do it. This one's a little bit prettier than the command line. And from a single point of management, right, what you're able to see is you're able to see statistics about what's happening across a collection of provisioned systems. And by provisioned systems, what I mean is when you install new ADB, what you're doing is you're provisioning a host. Right? You're not starting a database. You're getting those resources into the pool of resources where you can then decide, is it one big database, is it lots of small databases, is it a couple small, a couple big databases? What is, again, what's the resource management problem you're trying to solve? Each of those databases looks to the developer like a single logical consistent database. So operationally, you can decide what you're going to do separate from writing the code. And because I have a nice single point of management here, I can just decide that there are new things I want to be able to measure. So for example, I can say like, show me, this one will become interesting in a minute, show me network traffic breakdown. Right? So very, very quickly, very easily out of the box, you can start to measure key statistics that you care about from an operational point of view. And because this is a database product, I'm now going to start the database, because that's like, at the end of the day, that's why you use our software. But I'm going to do it a little bit differently than you might be used to experiencing, right? So this is running on Amazon. I've got some hosts provisioned on Amazon, but no database running, right? So what I'm going to do is I'm going to say, add a database. If anyone has used something like RDS or some other wizard, and you've wondered why you've got to walk through 5 screens and like pre-decide ahead of time all the storage limits and everything else, and that's frustrated you, this may be for you, what you're about to see, right? Because what I'm going to do is I'm going to start a database, I'm going to give it a name, I'm going to pick an initial DBA account, and then I'm going to pick a template. Right? And a template is that autopilot thing I was talking about. It is a service level agreement. Right? It's not a statement about where to run and how much disk to provision and whatever else. It's an abstraction, just like SQL is a declarative language to abstract, describing the problem you're trying to solve from how you actually run it as quickly as possible. Right? And so I'm going to start with the simplest database you can run in our system, a single host database. Click, say submit, it's going to go off, think about that. And then what we're going to have is we're going to have a database running called breakfast. And it's a, this is a leading edge developer build. It looks really pretty, but sometimes the refresh is. So it's running. You can see down here at the bottom, it says it's active, which is really all you care about. Right? It doesn't matter how it started, it doesn't matter what's going on. It is able to monitor itself and tell you that it's okay. It's running at spec, essentially. It's made up, as it happens, of 2 peer processes. I talked about those 2 kinds of processes, the storage manager, the transaction engine, the in-memory peer, the durability peer. That's what we've got. We've got these 2 things. They're running together. Security credentials all set up correctly, so it's talking over secure channels, yada, yada, yada. But what you care about is there's a JVC connection string now, or a .NET connection string, or whatever it is you want to use to talk to a database. It's a database and it's running. But at the moment, it's running on only one host, which is not very interesting from a distributed database point. So what I'm going to do now is live, I'm going to edit this database and I'm going to target it for a different service level. I'm going to say, actually, I've been doing some hacking for a while. I'm kind of probably ready to bring this in production. Let me change it to run in a minimally redundant configuration. By minimally redundant, basically what I mean is make sure that any host in the system can fail, and I've still got full access to my data, and I still can interact with the database through that in-memory view, right? So I'm good with any one host in the system failing. And I can do this live. And again, I can do this through the GUI. I can also do this through command line or APIs. And so what it's done is it's gone off and it's actually live, taken that database. Applications, if they were still running right now, they keep running. They're unaffected. Right, so this really is like a live operational thing I've just done. I'm now running across 3 hosts, and I'm made up of 4 processes, 2 of those in-memory peers and 2 of those durability peers. And so now, any one of these 3 hosts can fail, and I've still got a database running. Right? I didn't have to do anything. I didn't have to set up weird replication schemes. I didn't have to think about how to do additional backup techniques. It just kind of worked. Right? And what's cool is I can keep doing this. I was going to say I can keep doing this all day, except I can't because I'm out of time and because we're going to run out of templates. But just to make the point, I can now change and say, actually, you know what I really want to do now? I'll show you this earlier. So we're running in Amazon, and I've got hosts configured right now in Virginia, in California, and Oregon. They're all working together. But at the moment, this database that I've been running is only here in US East. Right? That's where if we go back and look at my database called Breakfast here. Look at the 3 hosts running on. You see they're all just in Virginia region. Right? So I've been scaling out, but I've only been scaling out in the Virginia region. So now what I'm going to do is I'm going to go back to my Breakfast database, and I'm going to change it one more time. And this time I'm going to say run against that geo-distributed template, which basically says, like, continue to run that minimally redundant configuration, but now do it in multiple locations. And again, still look like a single database. Don't affect any applications that are currently running. Just scale out. And it's still thinking. It's still kind of growing. It doesn't like move across geographies too aggressively because for those of you who haven't come across the word hysteresis, like, go look it up after breakfast, but that's why it's not spanning too crazy. But so there we go. So now, in like 10 seconds, we have a database that's running in all 3 of those Amazon regions I've configured. It's running on 12 machines. It's made up now of 16 peer processes that represent that in-memory component and durability. By the way, in order to create those extra points of durability, it's had to just automatically bring up new points of durability, synchronize data. And it's just running, and it's just a database. And this is kind of where I think the logical extension to what Matt was talking about gets really interesting, right? Because this is where we're going as an industry, is increasingly towards systems that have been architected from the start to really care about these problems of scale, distribution, to really understand why an architecture has to be able to support automation, why an architecture can support different models, why you might be scaling across multiple regions for availability or latency, but I might also be doing that because in a mixed model world, I want my operational transactions running on cheaper systems and my analytic transactions running on bigger systems in Amazon, and still make it look like a single database just with different caches, with different access patterns. Those kinds of problems are the things that we're trying to solve here at UADB. Those are the kinds of problems I think are increasingly interesting in the industry as a whole. I'll just leave this running so everyone I realize that 0 minutes per second isn't so impressive, but I promise it's a real database that's running. I just didn't think we'd have enough time to kind of set up an application against it as well. But I think that's all I had. And since we've been running over, I would ask Matt to come back up and we'll take a few questions. So thanks, everyone. Yeah.
We both use the term multi-model. Talking from the perspective of the application reference model or from the database organization and management model.
What do you think? I'll start with a specific use case, kind of lower level, and then you can sort of give some perspective to it. Here's a use case I've heard several times from large IT shops. Right? I've got my physical inventory, massive numbers of devices, right, my IT infrastructure. I've got them all in a relational database, so I can inventory them, so I know when I add something new, I can do depreciation, all the other stuff we have to think about realistically in an IT infrastructure. But because it's infrastructure, it also means that that router isn't just in my relational database, it's got a whole lot of cables coming out and connecting to other devices. And I really would like to be able to pose a hypothetical question. When I unplug one of those cables, or when I turn off a router, or when I change a firewall, I'd love to be able to ask the question before I do that, of what's about to happen to my system. Now that's not a relational problem, it's a graphical. And it requires being able to look at the data that I was originally querying through a relational model through what looks much more like a graph. But it's really the same data. It's just viewed from a different point of view. And when people talk graph, they often talk about columns. And what is a column store, right? A column store may be something about how you lay out data on disk, but it's really more about what you assume you can optimize. Right? Column stores work well in large part because they tend to be applied to problems where things like vertical partitioning are really useful, where dictionary compression may be really effective, where parallelization is really good, where you care about being able to pull information as selectively as possible off disk because every extra latency in the read has a amplitude effect on the overall length of the transaction. And so when I'm talking about multi-model, I'm really saying you may have data that's even the same data set, or at least is related in some fashion. But you want to be able to ask different questions or work with that data in different fashions. And there are different front-end languages you want to be able to use, different tools you want to be able to use for those queries. But there also now become different optimizations you want to make. And your system needs to have some way of understanding how to help you with those optimizations. And keeping it all inside the same database, first of all, simplification, right? It's a lot easier. But it also means that now if I really need to be able to do a relational query, find the infrastructure I'm talking about, form a query now to do some hypothetical analysis on it, go back to my relational model and actually make a change and register that I'm making that change. And I need all of that to be wrapped in the same transaction boundary. That's a thing that needs to be in the same infrastructure. So when I'm talking about multi-model, I'm kind of talking about that, that end-to-end view of the world that lets you solve some really interesting problems that are hard to solve if they're in separate databases.
Yeah, that's great. We're talking about basically the data storage model. I think a good example, hypothetical example of this. So, for example, you go into an e-commerce site, the initial things they want to figure out, you are you and you've been there before, and what did you do before? So potentially simple key value identify who you are. Then they want to deliver you some information about what you looked at last time, what you purchased last time, and what may therefore be of interest to you. Potentially, you might be using a document model for that. You then may want to look at what do people in your social network on this site purchase after they purchased that, and what are they looking at, what's interesting to them. Potentially, that's a graph problem. Then actually go through all that, you want to purchase something, that's a transactional system for that. So, if you think about that example, you could potentially do that, and lots of organizations do, with 4 or 5 different databases supporting what appears to the end user to be a single application. It could actually be multiple applications when it comes to it. Or, potentially, you look to do that on a single database that supports different models of those different aspects. But, yeah, as you did say, it does mean different things to different organizations, so it is something to bear in mind if you're talking to database suppliers or users. They can't talk about that.
Yeah, it's definitely, I'm not going to say that cloud means the same thing to everyone now, but just like 3 years ago, cloud definitively did not mean the same thing to 2 different people. I don't think multi-model has a clear, definitive term yet. I think in part because it's the point of view you come from. When you come from the point of view of doing DB and you say, well, it's all about that core architecture and what you can do. Multi-model becomes very much about that architecture can get you towards optimizations on different paths for the same data. When you talk to someone who's really focused on front-end technologies, they're probably going to say, well, multi-model means I can do SQL, I can do document, I can do whatever, and the data is there in the right format. So I think it's still early days on what that is really.
Thank you.
Yes.
I had a question for Matt. Matt, 2 questions. One is, and I'm sorry if I missed this in your presentation, you've got a dotted line for new SQL extension. I'm not seeing that on the map or any products.
Okay. It's a work in progress. So the new version, it's actually, for reasons we won't go into now, yeah, we got rid of that. There was basically, if you look at my SQL cluster, say, is it a new SQL database, is it? And obviously, it doesn't really matter, and so, I got with that at the time. Obviously, it was still, the line was still there on the map, even though the actual was gone, so,
Are there products associated with that?
not really. It was more a matter of, back to our requirement to kind of put things in the buckets. I just got a bit carried away with myself.
Other question real quick is Postgres XL, is that on here or would it be right next to
I think it is on the new version. Yeah.
Can we get the new version?
Yeah, we will send that. I think we're going to send it out to everybody. And it's also got, I didn't say, it's got the index on the back, so you don't need to run that list to. So yeah, I think we'll email that one out to everybody.
I have a question for you as well, Matt. So in this platform landscape map, what are your thoughts about companies that aren't necessarily pivoting, but almost trying to pick up their station and move it? Like, I'm looking at Postgres right now, and their enterprise DB is really pushing JSON pretty hard. And I think they're kind of ignoring the access language aspect of it, saying, yeah, we can do documents. Well, you can't take your Mongo app over, the wire protocol is different and such. So what are your thoughts about companies picking their dot up and moving it as opposed to sticking with their core competency and trying to make that dot just more substantive?
Yeah, it is interesting. We talk about this convergence, and obviously historically in the database space, what we've seen, and I talked about, the relational database model has just kind of absorbed all the challenges that came out, and the incumbent suppliers have done that. The question, so it's that classic. It's good enough for most people, but actually clearly, there's an emerging. We talk about emerging application requirements and use cases that it clearly isn't good enough, and that's why people turn to specialist databases in the first place. So, I think there's more than that, but I think,
Maybe adding sizes to these dots would be interesting in a
we have
future
thought
version of
about
this
it.
too.
That's just, just my head.
Give it to an intern.
Yeah, we should get some. That's good.
You should also have real estate prices, I was thinking.
There's lots, yeah.
And I have a question for you, Seth. So early in your presentation, you talked about companies that want to achieve massive scale need to start thinking differently. But then later in your presentation, you gave the example of, and I could name them, Box, Pinterest, Facebook, all these companies that are kind of not, they're succeeding without embracing this change. So is it your opinion, are they succeeding because of or in spite of their stack?
No, it's a great question. I think there probably are many reasons. Primary among them being that, I know some people at Box and Wickets are really good people, so not too surprising that they're doing well. I think there are a couple answers to that, right? One is the question of whether you're trying to build something new, whether you have something existing, right? So we certainly, I certainly spend a lot of my time talking to people who are in a mixture of that, right? Who have a lot of legacy systems or existing applications they put effort into that they're trying to move from a pure on-prem model to a service model or to a mixed model. Maybe it's cloud, maybe it's their data center, but are trying to get into that common model. And at the same time, they're building new applications, and they'd like to have some common infrastructure for that, right? When you look at something like Box, Pinterest, right? Something where someone essentially, or like good friends with the guys at Parse, so I know their story. When you look at those things, people who got to start from scratch and say, we've got a very small amount of time to scale something ridiculously. What works today? And they sat down and they built things on what works today. Right? I don't think they said we really want Shard or we really want active passive replication in our scheme. Right? They said this is what we know will work. We'll do it. And they built the application. I think at that time, I have been able to go to them and say, hey, actually, here's a database that just looks like a database. They'd probably be like, great. Yes, one fewer thing to worry about, right? So I don't think it's that I would never claim that you can't make things scale with existing technologies because there are too many counterexamples of that in the industry. I mean, they're Facebook, right? But very few people have the resources to be at Facebook. Very few people really want to kind of put that kind of engineering effort into something like that today. And I think given the option for something that just looks like a single thing that I can manage and is already cloud native, I think that's a preferable place to be. And then I think there really is this massive collection of applications that people are trying to modernize. Those are never things that you're going to be able to take in Sharp or take and say, well, consistency models aren't going to deal, or there are going to be delays in rights or something like that. Those are things that will always require a clear consistency model. So I guess that's the way to look at those kinds of applications.
Yeah, actually, tweet your words on it about how looking at this database space is actually an exercise in cognitive dissonance, holding two opposing beliefs in your head at the same time. There is definitely a considerable difference between the sort of things we're talking about, new projects moving to, and obviously all the existing projects, which people don't move their databases unless they really, really have to. And we do see that the landscape is changing, but it is going to take a long time because people don't throw away their databases. So, it's definitely there's different motivations for different universities.
Let's get a new person, yeah.
I would have a question, this is a good example. If Facebook using GoDB, would it have similar performance or it would be some drawbacks in the whole process as such? You know what I mean? So let's say where such a huge company could use, for example, GoDB.
Right.
And
Well, so Facebook, that's a great question. I'm going to punt a little bit. I apologize. Facebook is that's like a whole other hour conversation, right? Because Facebook is on this scale that is very unusual, right? I mean, we've done public demonstrations on the Facebook style benchmarks where we've taken public infrastructure and we said, well, there it is running at 2 million transactions per second. We don't usually push it very far because for most people they look at that and they're like, I've never hit 2 million transactions per second like that. Facebook is running at what is it now? 50, 60 million? Does anyone know the numbers today? I mean, it's something like that, right? I mean, it's on a different scale than almost anyone else thinks about. And so honestly, we have very rarely ever tried to say, well, what happens if we deploy 1,000 machines and try to push to that level of scale? Because that's really not where we test. We're much more interested in people who have operational nightmares and are trying to figure out how to solve them today. We are, the evolution of the product is towards much larger transaction quantities, much larger data quantities, because we think that's where the industry as a whole is going. But I couldn't tell you what would happen today if we tried to take the Facebook application and just make it about processing.
but there's a good chance that it could extend such pressure.
I think there are very few things in this world that could really handle the amount of custom engineering that they have done is just awesome. I mean, it's remarkable the amount of work they put into this, and it's a great example of what you can do when you want to shift resources and put money into the infrastructure and the resources and the engineers and everything else. And on the flip side of that, of course, right, there was a huge fire drill the first time someone complained, and they said, my coworker who's a woman saw this update before my wife saw it, and she was really angry. Right, and Facebook guys were like, you're right, she's on the same shard, and your wife isn't. Because when you first met, you weren't married, so we didn't put you on the same shard. Right, and literally there was like a 6-month engineering fire drill at Facebook to figure out how to solve that. Because that it ends up seriously, no kidding, anyone who's married understands that's a real problem. that's a real problem, right? And it's not a real problem for me because I actually use Facebook. I'm a little bit alive, I guess. But and joking aside, in any number of relationships, right? Not just for spouses. I mean, for any number of relationships, this is an important problem, right? When you're trying to do group coordination, you're trying to do other things around social networks, right? Being able to rebalance things. I mean, if anyone played online games over the last 20 years, right? This problem of online games scaling by sharding, and then trying to go back and figure out how you get all your friends together on the same shard so they can play together. There are games that famously that would be something you had to pay for, and it would take 8 hours to move you. It's by the way, everyone knows where the word shard comes from?
Glass.
From the gaming industry. Yeah, because that's actually one of the early online games couldn't make their system scale. They were trying to figure out how to make it scale. They couldn't figure out how to make it scale. And so they said, you know what we're going to do? We're a game. We're going to write into the story of the game, the backstory. The reason you're playing this game is because there used to be a single universe, and it existed, its spiritual energy existed in a single jewel. And one day some evil force came along and shattered that jewel. And so everyone's living in these disjoint universes, these disjoint shards. And so the goal is to somehow try to figure out how to reunite everything, which of course we do because it's scale. So it was genius. They actually embedded into the game. And that's why we got the word shard. But yeah, so I mean, you know, that's the flip side of this, right? Is could a existing system handle Facebook scale? I don't know. But Facebook today has all these incredible problems where they can't do things they want with their application. They can't fix certain communications problems. There are all these weird challenges, and it's because they have this architecture, right? And so it means that they're frantically trying to understand how do they expand and how do they grow what they can do given this architecture. So they're also going back to the drawing board and trying to figure, they're doing it for the other one. They're trying to simulate many fewer numbers of much larger machines and build on that technology, but it's a similar idea. We're out of time, so just wanted again to say thank you to everyone. Thank you to Matt for being here. And a couple of us will be around for a little while if folks have questions, want to chat more. But thanks everyone.